So hello friends, welcome you all. Welcome to this YouTube channel. So in the last lecture we were discussing about the percentage differential protection scheme. That's what you call it as a merged price differential protection scheme. In order to avoid the practical problem of the CT's current transformer, that is to eliminate the practical problem, that is unequal saturation levels, right? So due to an unequal saturation level of the two CTs, the CTs may maloperate, they may malfunction. So for that we have deduced the percentage differential protection scheme, right? So we have already discussed that in the last lecture, in the last video, right? So here let us go forward. So characteristic curve, by experiments. Now we shall practically discuss the characteristic curves. So by experimentation, for different values of operating force we find the restraining force, and for different values of restraining force we find the operating force, and we plot these values on a graph, right? So let us say that on this horizontal axis we have plotted the restraining force that we can obtain from the restraining current, that is basically average of the two currents, I1 plus I2 by 2. And here on the vertical axis we have plotted the difference of the two current, that is I1 minus I2, and I1 minus I2 is nothing but the operating coil current, relay operating coil current, right? So operating force we get from this operating coil current, that is I1 minus I2, that is the difference of two currents, right? That is the difference of two currents, right? So now let our original operating point is, let us say 2.2. Let us say original operating point is, or original operating point P is, original operating point P is 2.2 ampere, 0.2 ampere, let us say, right? So from the curve, operating force for an operating coil current of 0.2 ampere, that is equal to restraining force for a restraining current of 2 ampere. See here, for 0.1 ampere operating coil current, the restraining current is 1 ampere, and for 0.2 ampere operating coil current, the restraining coil current is 2 ampere. This is the characteristic curve that we have plotted by joining the points, right? So original operating point P is 2.2 ampere, 0.2 ampere. So this is the restraining force, x-axis is the restraining coil current, and y-axis is the operating coil current. So 2.2 ampere is the restraining current and 0.2 ampere is the operating current. So from this curve you know that operating force for an operating coil current of 0.2 ampere is equal to restraining force for restraining coil current of 2 ampere. So restraining force for 2.2 ampere restraining current is greater than operating force for 0.2 ampere operating current, or you can say restraining force for 2 ampere restraining current. So definitely the restraining force produced by the 2.2 ampere restraining coil current will definitely be greater than the restraining force which is produced by 2 ampere restraining coil current, right? So relay will definitely not operate. Because why? Because restraining force is more than the operating force. So below line AB, this characteristic, let us say this is the line AB, So below this line AB we get non-operating zone, right? So we have written here non-operating zone, right? So now let our original operating point is now Q, let us say, and this Q is, let us say, 1.5 ampere comma 0.2 ampere. So now in this case now see, in this case now the restraining force produced by 1.5 ampere restraining coil current is less than the operating force produced by 0.2 ampere operating coil current, or you can say restraining force produced by 2 ampere restraining coil current. So relay will definitely operate, because now in this case restraining force is less than operating force, so definitely relay will operate. So above this line AB we get operating zone. So we have written here operating zone above this line AB, operating zone above this line AB we have written operating zone, right? So percentage slope will be defined as difference of the two current, that is operating coil current, divided by average of the two current, that is I1 plus I2 by 2, that is basically average of the current, that is basically restraining force. So operating force by restraining force for percentage multiply by 100, right? So that is the basic percentage slope formula, right? Okay. Now let us say the slope is 10%. Let us say the slope is suppose 10%. So percentage slope is operating force by restraining force. So 10% is 0.1, so equal to operating force by restraining force. So operating force is 0.1 restraining force, or you can say restraining force is 10 times of the operating force. So if restraining force is greater than 10 times of operating force, a relay will not operate. Why? Because restraining force is more than the operating force. But if restraining force is less than the 10 times of operating force, then relay will definitely operate, because operating force is more here, right? So relay will definitely operate. So let us implement this percentage slope, that is percentage differential scheme, for providing the differential protection to provide the protection of a stator winding, right? Let us discuss this, how it works. So stator winding protection of generator using merged price circulating current method, right? So let us discuss this, stator winding protection of generator using merged price circulating current method. So for simplicity, only R phase winding is shown here and Y and B phase windings are not shown. So basically it's a 3-phase RYB, it's an alternator, right? Alternator is basically synchronous generator, so we have to provide the protection, differential protection using merged price percentage differential scheme, right? So here see this, this is R phase, this is R phase winding, right? This is R phase winding, all right? And here this is the neutral point, this is CT1 I have connected with CT ratio 100 by 5, this is CT2 I have connected, that is 100 by 5 CT ratio, right? And this is R phase winding, and here we have provided the operating coil, right, with n number of turns. This is the operating coil with n number of turns. This is the restraining coil, this is also restraining coil. So this restraining coil is having n by 2 number of turns, this is also having n by 2 number of turns, all right? So now let us see how it works. So in case number 1, percentage slope of the relay, let us say percentage slope of the relay is 10%. Let us say, let us assume that the percentage slope is 10%. So on this R phase winding, let us suppose the insulation is ruptured, right? That means breakdown of insulation has been occurred. So the insulation is ruptured and the bare copper wire touches the slot, right? Suppose a fault occurs and insulation is ruptured and the bare or naked copper wire touches the slot. Now the slot is embedded to stator body. Slot is embedded to stator body and this stator body is grounded. So wherever the copper wire touches the slot, an earth fault is created. An earth fault is developed, definitely, right? Why? Because of this earth fault, right? So slot is embedded to stator body and stator body is grounded. So wherever copper wire touches the slot, an earth fault is produced, right? So because of this earth fault, the current distribution is, suppose it is 110 ampere, right, current. Then out of this 110 ampere, 100 ampere goes to load, right? This is the load here in the right hand side. So 100 ampere goes to load for 110 ampere, 100 ampere goes to load and 10 ampere goes to ground, let us say, to the fault point where the fault has occurred. Suppose fault has occurred at this point, at this particular point, right? So 100 ampere goes to load, right, which is connected RHS of CT2, and 10 ampere to ground, right, 10 ampere to ground, and the direction of earth fault is from direction of earth fault is from copper winding, direction of earth fault is from copper winding to iron, right, from iron to ground and from ground to neutral, right? Direction of earth fault is from copper winding to iron and iron to ground and ground to ground and then ground to neutral, and from neutral it circulates, right? Okay. So now the question is, for 110 ampere current, fault current is 10 ampere that we have assumed, right? 10 ampere goes to ground to the from the fault point. CT ratio is 100 by 5 and if the percentage slope is 10%, if you set the percentage slope 10%, then will this really operate? Will this really operate or not? For percentage slope of 10%, will this really operate? So that is the case number 1 that we are analyzing, right? So CT1 primary current I1 is 110 ampere, current seen by the CT1 is 110 ampere, and out of this 110 ampere, 10 ampere goes to fault point and 100 ampere goes to fault, right? We have seen that in the earlier diagram. So for current seen by the CT1 primary, that is 110 ampere, and CT1 secondary current is 110 ampere into 5 by 100. By the CT ratio, CT1 secondary current is 5.5 ampere, right? Because current seen by the CT1 is 110 ampere. Now I told you, out of 110 ampere, 100 ampere goes to load, and that's why the CT2 primary current, the current seen by the CT2 primary is 100 ampere. So I2 is 100 ampere. So for this 100 ampere, CT2 secondary current is 100 into 5 by 100, that is 5 ampere, right? 5 ampere. Now operating coil current is I1 minus I2, that is 5.5 minus 5, that is 0.5 ampere. So operating coil current is 0.5 ampere. Now you have set the percentage slope 10% that you set. So for this 10% slope, operating coil current by restraining coil current, operating coil current is 0.5 divided by restraining coil current. So restraining coil current is 5 ampere, right? Now original restraining current 5 plus 5.5 by 2, I told you it is average. So 5.5 plus 5 divided by 2, that is 5.25 ampere. Now for the verge of operation, right, on the verge of operation, restraining force for restraining coil current of 5 ampere is equal to operating force for operating coil of 0.5 ampere. So clearly restraining force for restraining coil current of 5.25 will definitely be more than restraining force for restraining coil current of 5 ampere. Why? Because restraining force for restraining coil of 5 ampere is equal to operating force for operating coil current of 0.5 ampere. So for restraining coil current of 5.25 ampere, definitely the restraining force will be more than the restraining force for restraining coil current of 5 ampere, or you can say operating force for operating coil current of 0.5 ampere, right? So clearly relay will not operate. As simple as that, right? Because restraining force is more than operating force, right? Means relay is not sensitive to fault current of 10 ampere. Relay is not sensitive, right? Because relay is not operating, so it is not sensitive for fault current of 10 ampere for this 10% slope, right? For this 10% slope, the restraining force is more than operating force. That's why relay is not operating. That's why we said relay is not sensitive to fault current of 10 ampere. So if you plot this characteristic, if you plot this on this characteristic, vertical axis is basically operating coil current, that is I1 minus I2. So operating force is produced by operating coil current of I1 minus I2, and restraining coil current is I1 plus I2 by 2, that is basically average. So on horizontal axis we have plotted the restraining coil current, that is average of the two current, that is I1 plus I2 by 2. So here you see that this is basically the characteristic, right? So here for the restraining force for 5 ampere restraining coil current is basically operating force, that is equal to operating force produced by 0.5 ampere operating coil current. So this is the point. But here for 10% slope, restraining force will be given by 5.25 ampere restraining coil current, that is basically average of the two current, that is I1 plus I2 by 2. I told you earlier, right? So 5.25 basically is this point. 5.25 is more than 5, so this will come here, somewhere here. So that means it is coming below this line, that is basically non-operating zone. So relay will definitely not operate, right? Now, so in short I can say that slope say calculated RC restraining coil current, if it is less than original restraining coil current, the relay will not operate. But if slope say calculated RC, if it is more than original restraining coil, then the relay will definitely operate. What I said once again, restraining coil current calculated from the slope, यानी कि स्लोप से कैलकुलेटेड रेस्ट्रेनिंग कॉइल करंट अगर ये लेस है ओरिजिनल रेस्ट्रेनिंग कॉइल करंट से, तो रिले विल नॉट ऑपरेट. लेकिन स्लोप से कैलकुलेटेड रेस्ट्रेनिंग कॉइल करंट अगर ये ज़्यादा है ओरिजिनल रेस्ट्रेनिंग करंट से, तो रिले विल डेफिनेटली ऑपरेट, राइट. Now let us repeat the whole process with the different slope. Let us say in case number 2, the percentage slope is 5%. Percentage slope is 5%. Now let us say relay will operate or not. Let us say now. Let us analyze. So slope of 5%, 0.05 is equal to operating coil current by restraining coil current. So restraining coil current is 0.5 ampere. That we have calculated in case number 1, right? So 0.5 ampere divided by the slope, that is 0.05. So restraining coil current is 10 ampere. So restraining coil current is 10 ampere. So operating coil current is 0.5 ampere. Operating coil current of 0.5 ampere, right? That we have calculated in the case number 1. You put here and you get your restraining coil current, that is 10 ampere. Original restraining coil current is 5.5 plus 5 by 2, that is 5.25 ampere. So for the verge of operation, a restraining force for restraining coil current of 10 ampere is equal to operating force for operating coil current of 0.5 ampere, right? That is verge of operation condition. So clearly restraining force produced by restraining coil current of 5.25 ampere is less than restraining force produced by restraining coil current of 10 ampere. because 5.25 ampere is less than 10 ampere. So restraining force produced by restraining coil current of 5.25 ampere is less than restraining force produced by the restraining coil current of 10 ampere, or you can say operating force produced by operating coil current of 0.5 ampere, right? 0.5 ampere. So relay will definitely operate. Relay will definitely operate. Why? Because the operating force is more than restraining force in this case. Hence with 10% slope we cannot detect the fall current of 10 ampere, but by decreasing the slope to 5% we can definitely detect fall current of 10 ampere, because now the relay will operate at 5% slope. So that means as you are decreasing the percentage slope, the relay sensitivity is increasing. So I can say that relay sensitivity is proportional to 1 by percentage slope, right? So here the characteristic you can see here, for restraining coil current of 10 ampere, operating force is equal to operating force is produced by 0.5 ampere operating coil current. So this is the point. But if you decrease the slope, restraining coil is now 5.25 ampere current, 5.25 ampere restraining coil current. So 5.25 ampere less than 10 ampere. This on this horizontal axis, this is the restraining force, restraining coil current. On vertical axis, this is operating force, operating coil current. So 5.25 ampere less than 10 ampere. So now by decrease in the slope, you will get this point, right? So 5.25 ampere, that is the restraining coil current, comma 0.5 ampere operating coil current. So this point is coming above this line, that is operating zone. So relay will definitely operate. Relay will definitely operate for 5% slope, right? For this 5% slope, relay will definitely operate, right? Now let us say in case number 3, let us take fault current of 20 ampere, right? Fault current is 20 ampere and let us say percentage slope is 10%, let us say, right? So current seen by the CT1 primary is 120 ampere. Current seen by the CT1 primary is 120 ampere. So CT1 secondary current is 120 into 5 by 100. Why 120? Because our assumption is that 100 ampere goes to load, right? So CT1 primary current is 120 ampere. So CT1 secondary current is 120 into 5 by 100. That is the CT ratio. So 6 ampere. CT1 secondary current I1 is 6 ampere. CT2 current seen by the CT2 is 100 ampere because load is at the right hand side of the CT2, as we have seen in the diagram, right? So see this LU diagram, this is CT2 and this is CT1. So load is connected here, right? So current for 120 ampere current, 20 ampere goes to fault current, 20 ampere goes to fault current to the fault point, 20 ampere goes to the fault, and 100 ampere goes to load, right? In the earlier case it was 110 ampere, so 10 ampere was going to ground to the fault point and 100 ampere was going to load, right? So 100 ampere goes to load in this case also, and 20 ampere goes to ground. So current seen by the CT2 primary is 100 ampere. So CT2 secondary current will be 100 into 5 by 100, that is 5 ampere. So operating coil current is I1 minus I2, that is 1 ampere. So original restraining coil current is I1 plus I2 by 2, that is 6 plus 5 by 2, that is 5.5 ampere. So from characteristic, percentage slope is 10%. So operating coil current by restraining coil current is equal to 10%, that is 0.1. So restraining coil current is 10 ampere, right? Because operating coil current is 1 ampere. That is I1 minus I2, that is 6 minus 5, 1 ampere. So put 1 ampere here. So restraining coil current is 10 ampere, right? So now you plot this characteristic. The restraining force produced by restraining coil current of 10 ampere, that is verge of operation condition. Restraining force produced by restraining coil current of 10 ampere, that is equal to operating force produced by operating coil current of 1 ampere, right? What I said, restraining force for restraining coil current of 10 ampere is equal to operating force produced by operating coil current of 1 ampere. So this is the point, right? But for this percentage slope of 10% and fall current of 20 ampere, now the restraining force for restraining coil current of 5.5 ampere that we have calculated earlier, there's a original restraining current now, right? So restraining force for restraining coil current of 5.5 ampere is less than restraining force for restraining coil current of 10 ampere, or operating force for operating coil current of 1 ampere. So relay will definitely operate the circuit breaker. Relay will definitely operate because operating force is more than restraining force. Operating force is more than restraining force, right? So hope it is clear, right? So hope it is clear, crystal clear, right? So if you like the video, please subscribe this channel. Thank you very much. Thanks for watching. Thanks.